All right. So are you ready to dive in today? Because we're going deep.
Always ready.
Okay, awesome. Because we're looking at the work of Nakul Garg.
Okay.
And this researcher is doing some really incredible things with technology and sustainability,
Mm,
kind of rethinking the way we approach using tech in the world.
yeah.
And we've got some excerpts from his research statements.
Exciting.
It is really exciting. It gets a little technical, but I promise you it's going to be worth it. So what is it about Garg's work that really stands out to you?
You know what I think what's really fascinating is that he's not just, kind of like tweaking existing technology a little bit, trying to make it a little better.
Yeah.
He's going all the way back to the physics of it. Like, how do we actually sense things, and how
Right.
can we do that in a way that's just like radically more efficient?
So it's not just making something better, it's like rethinking the whole process.
Exactly. Yeah, it's like a fundamental rethink.
Okay, I love that. But give me an example, because I always need a good example to wrap my head around this stuff.
Okay, so let's talk about spatial audio sensing.
Right.
Figuring out, where a sound is coming from.
Yeah.
Usually that means a whole bunch of microphones.
Right, a whole array.
Exactly, which eats up a ton of power.
Yeah.
But Garg, he took inspiration from nature.
Owl ears.
Oh, wait, owl ears.
Yeah.
Okay, now you've got me intrigued. I definitely need to hear more about this.
So owls have these asymmetrical ears,
Oh.
and that helps them pinpoint sounds with incredible accuracy.
Wow.
And so Garg, he took that concept and basically 3D printed these microstructures that kind of mimic that,
Okay.
added some AI magic, and
Well.
created something called Owlet.
Owlet. I like it.
It uses a single microphone
Okay.
and these really clever structures to achieve the same kind of accuracy as a big microphone array, but using 100 times less power.
Hold on. So you're telling me he's basically doing the work of a ton of microphones with just one?
Yeah.
I don't even understand. How is that even possible?
It's really elegant physics.
Okay.
So these 3D printed structures, they're manipulating the sound waves
Yeah. Okay.
through diffraction and resonance.
Yeah.
So think of it like, you're setting up these carefully placed obstacles
Okay.
that create unique sound patterns depending on where the sound is coming from.
So each direction has its own like sonic fingerprint that the microphone can then pick up.
Exactly.
That's so cool.
And because the structures are doing most of the work,
Right.
the system needs way less processing power, which is usually the big energy drain.
Ah, okay, that makes sense. So less processing, less power needed. But how does this translate, to everyday life? Why should I care about owl ears and microphones?
Well, think about it this way. Truly wireless earbuds that last for weeks on a single charge,
Okay, I like where this is going.
because they're barely using any power to process the sound.
Oh my gosh, yes, please.
It's just one example.
Hmm.
You could have hearing aids that are way better at isolating conversations in noisy places, or smart home devices that can actually pinpoint the source of a sound,
Mm-hmm.
all while using minimal energy. It's a potential game changer in so many areas. It's not just cool, it's incredibly practical.
Yeah.
And speaking of practical, you mentioned tiny robots earlier. And I have to admit, I'm picturing like something out of a sci-fi movie, little robots buzzing around doing all kinds of amazing things.
Yeah.
What's Garg doing in that space?
So with Spidey R,
Okay.
he's really pushing the boundaries of what these micro robots can do.
Okay.
And one of the big challenges is these little guys need to be able to perceive their surroundings, figure out where things are, how far away they are, to be able to move around effectively.
Like depth perception.
Exactly, depth perception.
Yeah.
But the usual solutions like LiDAR, they're way too energy intensive and bulky for something, the size of an ant.
Right. So he didn't just like shrink down a LiDAR or something.
No, he went a completely different route. He's
Yeah.
using sound instead of light for depth perception.
Okay. I did not see that coming. Tell me more.
So Spidey R has a speaker, a microphone, and the specially designed stencil. Think of it like a complex 3D printed acoustic lens.
A stencil for 3D depth. I don't quite follow.
So the stencil, it's like the secret sauce of the whole system.
Yeah.
It's designed to create a unique acoustic signature for every single point in space.
Yeah.
Kind of like how Owlet uses those structures to create direction-specific fingerprints, but in 3 dimensions.
So the robot sends out a sound, and by analyzing how that sound is distorted by the stencil, it can figure out distances and build like a 3D map.
You got it.
Wow, that is incredible. And how much more efficient is this compared to other methods?
About 400 times more energy efficient.
Okay, 400 times that officially qualifies as a game changer.
Definitely.
So now we're talking about tiny robots that can explore disaster zones,
Yeah,
maybe even navigate the human body for medical procedures,
absolutely.
all without needing these big, bulky batteries.
Exactly.
The possibilities are kind of endless.
They really are.
Yeah.
And because it uses sound, it can work in places where cameras and LiDAR would have trouble, like dusty or smoky environments.
Okay, my mind is officially blown. It's like Garg just keeps finding these elegant solutions by thinking completely outside the box. But I have a feeling this isn't all he's up to, right?
Oh, you have no idea. We've only just scratched the surface.
Oh man, I am on the edge of my seat. This is better than any sci-fi movie.
Oh,
We're going to dive into all of that right after this quick break.
can't wait. And you know what else is really cool?
Okay, lay it on me.
Tracking systems.
Okay, wait. We've gone from owl ears and microphones to tiny robots with sonic vision.
Yeah.
How do tracking systems fit into all of this?
Well, imagine being able to track anything
Okay.
from a shipment of, fresh produce
Yeah.
to your lost keys
Right.
with incredible accuracy, all using these tiny battery-free tags.
Did you say battery-free?
Yeah, battery-free.
How is that even possible?
Or-
Don't most tracking systems use like GPS, which is a total energy hog?
You're right. Traditional GPS does use a lot of power.
Yeah.
But Lightfoot, this is what Garg came up with, it uses a totally different approach.
Lightfoot, okay, I like the name. What does it do?
It uses existing cellular signals to figure out location.
So it's like piggybacking on the signals that our phones are already using?
Exactly.
That's pretty clever.
Yeah.
But how can you get an accurate location from those signals?
That's where the real magic happens.
Okay.
It uses some really sophisticated signal processing
Okay.
to pull out location information from the signals coming from cell towers.
Huh. So it's kind of like triangulating your position based on the strength of different Wi-Fi signals,
Yeah.
but on a much larger scale, using the whole cellular network.
Exactly.
So instead of needing a big GPS receiver
Right.
and a power-hungry battery,
Yeah.
you could have a tiny little tag
Right.
that basically sips power while it's tracking its location.
And the energy savings are incredible. We're talking about Lightfoot using like 625 times less energy than traditional GPS.
625 times. Okay, you officially have my attention.
That means these tags could last for years on a tiny battery, or even be completely battery-free if they can just harvest a little bit of energy from their surroundings.
So we could track food shipments to reduce waste,
Exactly.
keep tabs on vulnerable people, even find lost luggage.
Absolutely.
Without those annoying tracker pegs that always seem to die at the worst possible moment.
Exactly. And since it uses the existing cellular network,
Right.
you don't have to build any new infrastructure.
It's scalable and sustainable.
Exactly.
Okay, Garg is hitting all the right notes with these projects.
He really is.
Energy efficiency, sustainability, real-world applications. But I know there's more.
There's always more.
All right. What else has he been working on?
Let's talk about food waste.
Okay.
Did you know that almost a third of all food produced globally ends up wasted?
Yeah, that's a crazy statistic. It's a huge problem.
It's massive, both for the environment and the economy.
Yeah, I try to be mindful of food waste in my own life, but it's hard. You know, it's a big problem.
It is. And a
Yeah.
lot of that waste happens during transportation and storage. You know,
Yeah.
food going bad before it even gets to the store.
That's right, which is where Fresh Sense comes in.
Exactly. Fresh Sense.
Okay, that sounds like something straight out of a sci-fi movie. What is Fresh Sense?
It's a wireless sensing system that can monitor food quality without having to open packages or even touch the food.
Hold on. You're telling me you can see inside without opening anything?
Kind of. It uses radio waves.
Radio waves.
Yeah, kind of like Wi-Fi.
Okay.
But instead of transmitting beta, it analyzes how those waves change as they pass through the food.
So different types of food and food at different stages of freshness will affect those waves in different ways.
Exactly. And by analyzing those changes, Fresh Sense can tell things like moisture content, which is a big indicator of how fresh something is.
This could revolutionize how we manage food.
Absolutely.
Imagine grocery stores with smart shelves that automatically track the freshness of produce
Yeah.
and adjust prices accordingly.
Exactly.
That would drastically reduce waste
It really would.
and make sure people are getting the best quality food.
That's the idea. It could be a major step towards a more sustainable food system.
It's amazing how Garg keeps coming up with these incredibly practical solutions
I know.
to complex problems. From owl-inspired microphones to tiny robots to tracking systems that don't need batteries, and now this.
Yeah.
It's incredible. Is there anything he hasn't thought of?
Well, he's always pushing the boundaries of what's possible.
Well, of course he is.
And he's got some really ambitious, moonshot projects in the works that are worth talking about.
Moonshot projects.
Oh.
All right, now you're speaking my language. Tell me everything.
So one area he's exploring is something called space IoT, Internet of Things in Space.
Internet of Things in space?
Yeah.
What does that even mean?
Imagine a network of tiny, ultra-low power sensors
Okay.
orbiting the Earth, constantly monitoring our planet.
So instead of having these big, expensive satellites,
Yeah.
we could have a whole swarm of tiny sensors
Exactly.
collecting data on deforestation, pollution, climate change. It's like giving the planet a nervous system.
That's a great way to put it. And because these sensors would be constantly talking to each other,
Right.
they could send data back to Earth in real time,
Wow.
giving us a much better understanding of how our planet is changing.
That's a brilliant idea.
Yeah.
What else is he working on?
Another really fascinating area is neuromorphic 3D perception. He's basically trying to create systems that see the world the same way biological systems do,
Okay, how do you even begin to do that?
using highly efficient event-driven sensing and processing.
So instead of constantly capturing every single pixel,
Yeah.
these systems would only focus on changes in events
Right?
that are actually relevant, much like our eyes and brains do.
Exactly. And this could lead to incredibly efficient 3D vision systems for robots, drones, wearable devices, all using a fraction of the power.
It's like he's constantly reimagining what technology can be.
I know, it's amazing.
It's not just about, making things a little bit better.
Right.
It's about fundamental shifts in how we think about sensing computing and interacting with the world.
Yeah. And it's all driven by a deep understanding of physics
Yeah.
and a real commitment to sustainability.
So it's not just about the tech itself.
Yeah,
It's about the bigger picture.
absolutely.
He's not just building gadgets. He's creating a vision for the future.
Hmm.
But before we wrap up our deep dive into Garg's work, is there anything else that really stands out to you? Anything particularly exciting or thought-provoking?
It's incredible how he's not just doing this research in a vacuum,
Yeah.
He's actually working with companies and institutions.
So it's not just theoretical.
No, it's very practical.
This stuff is actually being developed right now.
It is.
It could be in our lives soon.
Exactly. And that's
Yeah.
what makes it so exciting.
Yeah, it's not just some, far-off sci-fi future.
Right.
This is happening.
Yeah, and it's not just about, the technology itself.
Yeah.
It's about using it to create a better future.
A more sustainable future.
Exactly, a more equitable future for everyone.
I love that.
Yeah.
So for our listeners who maybe are feeling a little overwhelmed right now,
I understand.
by all this amazing tech, what would you say is the key takeaway from our deep dive into Nakul Garg's work?
I think it's that the future of technology isn't just about, more power, more speed.
Right.
It's about understanding the laws of physics and using that knowledge to create systems that are incredibly efficient, sustainable, and, really integrated with the world around us.
It's like he's found a way to make technology work with nature,
Yeah,
not against it,
exactly.
using its power to actually enhance our lives and protect our planet,
That's it.
not drain its resources or, create more problems.
Exactly.
It's really inspiring to see someone pushing the boundaries like this,
Yeah.
while keeping the bigger picture in mind.
Absolutely.
So as we wrap up this deep dive, I want to leave our listeners with a final thought.
Mm-hmm.
Imagine a world where technology is so efficient and so integrated that it basically disappears.
Wow.
A world of tiny, ubiquitous sensors, where robots work alongside us. We can track anything we need without bulky batteries or, complicated infrastructure.
That's a powerful image.
It is. What else do you see?
A world where food waste is a distant memory.
Yeah.
Our environment is constantly monitored and protected, and technology empowers us to live healthier, more sustainable lives.
That's the future Nakul Garg is working towards.
That is.
And it's a future that, thanks to his work, feels a lot closer than we might think.
Absolutely.
So keep your eyes open, listeners. The future is about to get a whole lot more interesting.
And until next time, keep exploring, keep questioning, and keep diving deep.
And remember, the most incredible discoveries are often hidden in the most unexpected places, just waiting for a curious mind to uncover them.